Hi everyone, I am Abhinav and welcome to the post-contest discussion of the Codechef Starters round 175. Okay, so before starting with the discussion, let's discuss with you the all-new CP31 sheet, which has a new version launched, which contains the 31 handpicked problems from all the ratings from 800 up till 1900. Okay, and it contains some carefully chosen problems. Every problem teaches you a new idea, so it's recommended that you must try it. Okay, so it has been upgraded with a new interface where you can just connect your Codeforces handle with it, and after connecting your Codeforces handle, your all the progress from your Codeforces would be fetched here. So all the problems that are solved by you would be automatically fetched here. Okay, so added to this, every week we'll be releasing 7 to 8 video solutions of all the problems. So, okay, starting with the 800, so the solutions are already being released. So every week 7 to 8 problems, the solutions would be released. So if you're stuck anywhere, you can watch the solutions on the TLE Eliminators YouTube channel. Okay, so you can find the link to this seat in the description of the PCD. So now let's get started with the PCD. Okay. So today we'll discuss the from div to the first three problems and the fifth problem. Okay, so let's get started with the first problem, which is make same. Okay, so let's read the statement that you are given three binary strings, S1, S2, and S3, all of length n, and your goal is to make make each string contain identical characters, either all zeros or all one. Okay, so to achieve that, you can perform three types of operation. First is choose x and y among 1, 2, or 3, and two indices I and j from 0 to n, and then swap sxi with syi. That means among the three strings, you chose any two of the strings. Okay, among 1, 2, 3, you chose any two of the strings. And for the two of the strings, you chose an index I for the first string and an index j for the second string. And you swapped both of those, index I of the first string and index j of the second string that you chose. You swap them. Okay, find the minimum number of operations required to make each string contain identical characters and print -1 if it is impossible. Okay, so this is the problem statement. If you so let's take one test case and understand it better. What we are what we are it is saying. Okay, so you are given an n, and then you are given three strings, S1, S2, and S3. All of them are of length n, and these are binary strings, so it would contain only 0 or 1. Okay, after that, what you need to find out is you can just select any two of the strings. Okay, let's say you selected S1 and S2. Okay, so if you select x equal to 1 and y equal to 2, that means your first string is S1, second is S2, and then you'll select two indices I and j. Let's say you selected I equal to 1 and j equal to 2. That means in the first string, you are selecting the first index. Okay, if I'm indexing in one based index, then you're selecting this first index, and j equal to 2 means in the second string, you're selecting this index, and then you would swap both of them. Okay, so this is this is the operation that you can do. Basically, you can swap any two indices from any two different strings. Okay, you can just swap any two of the things from two different indices. You can just swap anything. Okay, so this is one operation. Now you need to find the minimum number of operations required so that all these three strings are such that they only contain one type of character. Either they contain all the ones or they contain all the zeros. Okay, so when all of the three strings become like that, then your work is done. So you need to achieve that thing in minimum number of operations. So for example, in this test case, what you can do in minimum number of operations, so you'll apply your operation 1. Okay, what you can do in this string, you can see it is already all zeros. So I think there is no need to change that. And these two strings contain mix of zeros and ones. So once you can do, you can swap this one with this 0. What would happen? It would become 1, it would become 0, it will contain all zeros and all ones. Okay, so you select x equal to 1, y equal to 3. These two strings are selected, and then this index and this index is selected. So I equal to 1, j equal to 1. Okay, when you perform this operation, this would become 1, this would become 0. What you would get? 000, 000, and 111. So in one operation, you are able to achieve this thing, that all zeros or all ones in all the three strings. Okay, so your answer to this would be 1. So minimum number of operations required would be 1. So for first test case, you can see answer was 1. Okay, so I hope the problem statement is clear to you. Now, what you need to do in order to achieve this. Okay, so the first thing to notice here is in the operations, you are allowed to only swap any two of the basically characters. You cannot change a 0 to 1 or a 1 to 0. So overall, in the three strings, whatever is the total number of zeros and the total number of ones, that would always remain constant. That you can like observe very clearly, that here if the total number of zeros was 1, 2, 3, 4, 5, 6. So total number of zeros, the count of zeros was 6 here, and the count of ones was 1, 2, and 3 here. So even after performing any operation, this count is not going to change, the total count of zeros and ones. So what is the condition? That if your final string is like this, all zeros or all ones or all zeros, okay, so that means the three strings that you get finally, they should contain either all zeros, all ones, all zeros, something like that. So in your final string, the total number of zeros and the total number of ones, either there would two of the strings would be 0, 0, or three of the strings would be 0, 0, or only one string would be 0. They all would be the total count of zeros should be divisible by n. I think you can clearly observe that is the basic condition. If it is the case is something like this, then there are 2n zeros and n ones. Okay, so what all can be the valid possibilities? The count of zeros and count of ones. Either there is 3n zeros or and no one. All the three are 3 zeros. Either 2n zeros or n times 1, or n zeros 2n times 1, or 0 zeros and 3n times 1. Okay, so these are the only 4 cases in which you would get an answer. If the total count of zeros and ones are not among any of these 4 cases, then your answer would be -1. You just cannot make it. Okay, I hope you understand it. So that's the first thing. So the first thing you would do is find the count of zeros and ones. And if that count is not divisible by n, okay, so if any of the count is not divisible by n, you will directly print -1. Okay, so that's the first thing. If the count of zeros or count of 1 is not divisible by n, then you print -1. Okay, that's the first conclusion that you get. Now, after that, how do you solve the problem? How do you calculate the minimum number of operations? Now you have 4 cases. Okay, just analyze these 4 cases. For these 2 cases, where there are all zeros or all ones, then how it would be? It would be all zeros here and all zeros here, all zeros here, or all ones here. So that is already in the form that you want. So in these 2 cases, your answer would be no operations is needed, because the 3 strings already have either all zeros or all ones. So the number of operations required would be 0. So for these 2 cases, you can directly answer 0. So the only thing you need to handle are these 2 cases. Okay, so when the number of ones is n, number of zeros is 2n, or when the number of zeros is n, number of ones is 2n. Okay, so whichever is lower. For this case, I'll check for 1. Okay, when the number of ones is n, then what I'll check in the 3 strings, like here, the number of ones was 3, it was n. So there would be, in my final answer, there would be one string which would be all 1, and remaining strings would have 0. So if you accumulate all the ones that are present in the 3 strings into a single string, then remaining would become 0 automatically. So you need to decide which would be that string that would contain all the ones. So you can just try out for all the 3 strings. Okay, so first we'll assume that S1 contains all the ones finally. So what would be the number of operations needed? If S1 had to contain all ones, it already has 1 1, so 2 zeros are there, so 2 swaps would be needed at least. Okay, so number of zeros present in S1 would be the number of swaps needed if you have to make it all ones in S1 and zeros in the rest. So for that case, it would be the count of zeros in S1, or you can say n minus count of ones, that they would be same. So with C10, I'm representing the count of zeros in S1. So either this, or if you make S2 contain all the ones, then the count of zeros in S2 is the number of swaps you need to do. So count of zeros in S2, or if you make S3 as all the ones which you are making actually, then the count of zeros in S3. So the count of zeros in S3. So the minimum among these three would be your final answer. Okay. So simply for the case when for this case, your final answer would be the minimum among count of zeros in S1, count of zeros in S2, okay, or whatever. There I was representing it like this. And count of zeros in S3. And for this case, since zero is the, you have to make all zeros in one of the strings, then it would be okay, or all zeros in another. So the count of one would be the number of swaps that you need to do. So the count of ones in S1, count of one in S2, and the count of one in S3. That would be your answer. Okay. So your problem is solved, I guess, with this logic. If it is not divisible, then print a -1. If it is divisible and there is a either there is 0 times 1 or 0 times 0, then print 0. And for these two cases, if number of ones is n, your answer is this. If number of zeros is n, your answer is this. So for all the cases, your problem is solved. I hope the logic is clear to you. So if you move on to the code, how do you do that? It's just case making. So first I calculated the count of, okay, this is the count of zeros in my string S1. Okay, C10, count of zeros in string S1, count of zeros in string S2, same way count of zeros in string S3, and same way count of ones in the string S1, S2, S3. So I calculated these three using my count function. And then my total count of zeros is the sum of counts in all the three strings. Total count of ones is 3n minus C0 you can write, or you can just also write sum of these three. Okay, it would be the same. So if either C1 or C0 is 0, then I print 0. Okay, so if either of these, if it is either of these cases where C1 is 0 or C0 is 0, my answer is 0. And if C1 is not divisible by n, so T1 mod n is not equal to 0, then I print -1. Okay, so these cases are done. Okay, my -1 case and 0, 0 case. Now these two cases remain. So for that, if C0 is n, if C0 is n, it is this case, I print this as my answer. So n minus the count of ones is same as the count of n minus count of zeros is same as count of one. Okay, so like you can write like this, or you can also write this directly. It would be same. So this, and in the else case, you write this. Okay, and then you print your final answer. I hope this problem is clear to everyone. The time complexity would be for all these count function, it would be the order of n for each of the count functions, so order of n, because for counting, it runs through all of them. So complexity for count would be n. So order of n is there 6 times, and these are all if-else conditions, just so order of 1 for them. So overall, the time complexity would be order of n. Okay, and the space complexity would be, I think you are using just input, the 3 strings of the input is only used, no extra space is used. Okay, so if you consider the input space, then 3 strings of size. Okay, so let's move on to the next problem now. If there is any doubt in this problem, you may ask, or we'll move to the next one. Okay, so let's move to the next problem, which is alternate it. Okay, so in this problem, we are given a binary string S. You can perform a series of operations on it any number of times. Okay, so You are given a binary string S and you have to perform a series of operations. So the odd operations or the first, second, fifth, those operations would be like this. You can shuffle any substring of S in any order. Okay, just select a substring of S and shuffle it in any order. Or for the even numbered operations, so the second, fourth, sixth operation, what you can do is you can choose any substring of S and flip every bit of it. Okay, so every bit of that. So since you have a binary string, either 0 or 1, so the zeros would become 1, 1 would become 0 in that substring. Okay, so yeah, find the minimum number of operations performed to make the string alternating. What do you mean by alternating string? It is either 0 1 0 1 0 1 0 1 or 1 0 1 0 1 0. Okay, so no two adjacent characters are same. That's what an alternating string is. Okay, so I'll explain you with the test case. What does the problem statement states? Okay, so you are given. Okay, you are given a single string. Okay, these are three test cases. You are given a single string as input, just that. Okay, what you need to do is you want to make this string as alternating string. Okay, so alternating string means 1 0 1 0 1 0 1 0 1 like that, or start with 0 and 0 1 0 1. Okay, so if the string becomes like this, that is there are no two consecutive characters which are same. After 1 there would be 0, after 0 1, after 1 0. Okay, so no two characters are 1 1 or 0 0. Then this string is called alternating. Here if you see, is this string alternating? No, there are 2 1 1 together, 2 0 0 together, so this string is not alternating. So you need to make this string alternating. How do you make this string alternating? You have a series of operations. Okay, so in the first operation, what you can do, so for all the odd operations, so first operation would be an odd operation. There you can do this thing, that you can select any substring and shuffle its order. So let's say you selected this substring, okay, and you selected this substring and you can just shuffle its order in any way. Okay, so the remaining string remains the same, and let's say you shuffle this particular thing, instead of 0 0 1 it becomes 1 0 0. Okay, that's what shuffling is, and then this 0 would remain 0. So the string would become like this after the first operation. Okay, so this is just one example what you can do. Select any substring and shuffle its characters. Okay, you can move it here and there, but the count of zeros and ones in them would remain same. Okay, their positions can be shuffled. And in the even operations, you can choose any substring of S and flip every bit of it. Okay, so in operation 1, you can do that. In operation 2, since it is an even operation, what you can do is select a substring. Let's say you selected this substring, then all the bits would be flipped. So this 1 would become. Okay, so we'll not do that here. Let's say my operation is already performed. This is my string. So in that, maybe I can select this substring and all the bits would be flipped. So all these ones would become 0. And if there was 0, it would become 1. For the remaining part, it would remain same. Okay, so this is one possibility of doing the second type of operation. After this, your string becomes like this. Okay, then again, you will do in operation 3. Again, it is an odd operation, so you'll do the what you did in the first type, select a substring and shuffle them. Okay, so like these, you can do the operations, and you need to find in what is the minimum number of operations you need so that this string becomes an alternating string. Okay, so for this test case, what was my best possible answer, best way to do the operations? It was that what you can do is, since during the first row, we can select the entire string as substring and shuffle it. Okay. So in the first operation only, what you can do, you can select this entire string as substring. You have 3 ones and 3 zeros. So you can just simply shuffle them up. Okay. You selected this entire string and just shuffle them up to be like this 1 0 1 0 1 0. Okay. Now this string is alternating. So in one operation only, it is done. So your answer was 1 here. Okay, for first test case, your answer was 1. If you see the third test case, let's take the third test case. What would happen? Okay, if you take the third test case, what would happen? Now, here there are 4 ones and 2 zeros. So even if you select this entire string and shuffle them, you cannot make it like 1 0 1 0 and then 2 ones would remain. They would become consecutive. So if you have to make them alternating, first thing is the number of zeros and ones should be either same or they differ by 1. Like 1 0 1, there would be 2 ones and a 0. 0 1 0, 2 zeros and a 1, or they are equal. Okay, so the condition for alternating string is that in an alternating string the count of zeros is either equal to the count of 1 or they differ by just 1. So count of zeros minus count of 1, the absolute value is either 0 or 1. Okay, so either they are equal or their difference is 1. Then only the string can be alternating. This is the most basic condition for alternating string. So here the count was 4 ones and 2 zeros. So when you shuffle the string in type 1 operation, so in the operation of type 1, when you shuffle the string, you are not changing the counts of zeros and ones. They are the same. So in one operation, you can never make this string alternating because the count of zeros and 1 was not same or differ by 1. Okay, so you cannot do it in one operation. Okay, so can you do it in 2 operations? So what you did here is you basically in first operation you selected an empty substring. Okay, you just selected an empty substring and performed the operation on it. That means you did nothing. Okay, so you can also do like that. You can select an empty substring and perform operation on it. That means you did nothing. And in the second operation, you selected this substring and flipped its character. So it became 0 and my final string became 0 1 0 1 0 1, which is alternating. Okay, so in 2 operations you were able to do it. So answer for this was 2. Okay, so I hope you got an intuition, a little bit of logic just by analyzing the test cases, that what all things you can do. Now, what exactly, how do you find the minimum number of operations? Okay, so the first thing is, let's do it again case wise. If the string is already alternating, okay, so what do we have? The string is already alternating. You don't need to do anything, so 0 number of operations required. Okay, then the condition is if the number of zeros and ones satisfy the condition for alternative, that is the count of zeros and count of 1, this absolute value is less than equal to 1. This is the condition. If it is possible to make the string alternating, then in an alternating strings, the count of zeros and ones should not be greater than 1, as we had proved here. Here it would be 0 or here 1. Okay, so I hope this thing is clear. You don't need a proof for that. If this is the case, then you can select the entire string as a substring and shuffle them in the first operation to make it alternative. Okay, so in this case, you will require only one operation, that is the first type operation, shuffle them and make it alternative. Now, what happens in these cases when there are more than, when these two conditions are not satisfied? If it was already alternating, okay, it was not alternating. The count of zeros and ones was also not equal to 0 or 1. So in one operation, you cannot make it alternative. Can you do it in 2 operations? That's the question. So here you were able to do it in 2 operations because in first operation you did nothing. And then here it was like 0 1 0 1 already alternating. Only at one place there was some consecutive ones which got replaced by. So this second operation can be also taken as just select a single index as a substring and swap it from 0 to 1. So this way you are changing the count of zeros and 1. Initially it was like this. After performing the operation, 1 was converted to 0. So count of zeros became 3, count of ones became 3. Now this condition was okay for changing it to, basically this condition was okay for that. Now here only you already got alternating. If it was something like that, like you had, okay, let's say you had 1 1 0 0 1 1, something like that. Okay, so then even after the second operation, let's say you performed on this and made this 1 as 0, you have 3 ones and 3 zeros, but it is not alternating. Then you would require a third operation to shuffle it and make it alternating. Okay, in that case. So now you need to see if you can do it in two operations or you need to require a third operation as well. And when do you require more than three operations? Okay. So the first thing I'm telling is you can always do it in three operations. How? So that's the first thing you can conclude with observation, that you would never require more than three operations. So be it any string. Okay, so I'll show you that. So be it any string. Okay, whatever binary string you are is given to us, 0011 010, anything. Okay, what you can do is, if it doesn't have the count of zeros and ones same, or they differ by a huge margin, what you can do in operation one, do nothing. Okay, that is select an empty string. In operation two, what you can do, okay, sorry, not do nothing. What you can do in operation one, shuffle the string like this: all zeros on one side, all ones on other side. Okay, whatever that string is, make it like this: all the zeros on one side, all the ones on other side. In operation two, what you do is select, if there were more number of ones, let's say the number of ones here, you can see 1 2 3 4 5 6 7 8, 8 ones were there, 4 zeros were there. So what is the condition for alternating? Zeros and ones should be same or differ by one. So out of 12, it should be 6 6. So you can just turn these two ones into zeros. Okay, so you can just select these substring in your second operation, make them 0. Now the count is 6 6. Then in the third operation, you can shuffle this again and make it 0 1 0 1 0. Okay, so be it any string, you can always make it like this in first operation. Second operation, just equalize the zeros and ones. And in the third operation, shuffle again and make it 0 1 0. So in any case, you would never require more than three operations. That is done. Okay. So that I have proved that in three operations, you can always do. Okay. So for this case, you can do in zero operation. For this case, you can do in one operation. Okay. If it is not either this or that, so in the else case, your answer is either 2 or 3. So you just need to decide now, can you do it in two operations or not? If you can do it in two operations, your answer would be 2. If you cannot, then your answer would be 3. Because we have proved that in three operations, you can always do. So can you do it in two operations? That's the thing that we need to find out. Okay, so for two operations, what is the condition? Like in first, you can shuffle the array, something like this, and in second operation, change some 0 to 1. But even after doing that, it may be possible that it's still not possible to convert it. Like, let's say you have 1 2 3 4 5 6 7. Okay, something like this string is given to you. In first operation, you can shuffle it in any way. But even if you apply the like in second operation, what you are doing, you are selecting a substring. Okay, just look at the second operation. So in type 1 operation, your count of zeros and ones are not changing. Okay, whatever it is initially, it would remain same. With second operation, you can change it, but how far can you change it? If the count of zeros was, let's say, here you can see 2 and count of 1 was 6. Then with the second operation, what I'm trying to prove is you have a string in from that, like you have a string from that, you select a substring. Okay, you have a string from that, you are selecting a substring. So whenever you select a substring and flip it, how is my count of zeros and ones changing by what factor? Is, if you try to think, then if that substring contains, if in that substring, just in that substring, there are, let's say, two ones and two zeros and one one. Okay, whatever. After it is flipped, it becomes 1 2. Okay, so whenever whenever you basically select a substring and flip it, and after that you want to say that after second operation only my string has already become alternating, that means you are only changing in that substring. For the remaining string, it should be already alternating, then only you can do it in two operations. So what is the condition? That in this substring, when you are flipping it, so basically if it was not alternating, something like that, then even after flipping, okay, if that substring was not alternating, then even after flipping, its status of alternating or not is not going to change. Okay, so inside that substring, if it was not alternating, it would still not be alternating. If there was some consecutive zeros, it would change to consecutive ones. Okay, that's the thing what I'm trying to prove. So you would apply the second type of operation only like this, that the substring you would select would be a single character, okay, which is, let's say, 1, and you change it to 0, and now the string becomes alternative. So if after the first operations, the difference between the zeros and ones is like 2 or 3 only. So that difference you can just reduce by selecting a substring and make it alternating again. But if the difference is more than that, then whatever like shuffling you do initially, okay, if it was like this, whatever shuffling you do initially, okay, anything like this, you cannot like if you have you cannot make all these. Even if you make both of them 0, you would have 2 0. If you make one of them 0, you would have 1 0. Okay, so in this, just after the second operation, you cannot make this again alternating. You would require a third operation again. A reshuffling would again be required. So only case when you can make it alternating, if after the first operation there was just one extra 1 instead of a 0. Okay, only the ones was exceeding the zeros by 1 extra. Just by swapping a 1 to 0, you can again make them equal or make them differ by 1. Then only you would say that you'll shuffle it like that, so that there are 3 consecutive ones, and make a 1 0 in the second operation and make it alternative. So only for that case you can basically do it in 2 operations. That's what I'm trying to prove you. Yes, somebody has written, if the absolute difference between number of zeros and ones is less than 4, then the answer is 2. So why is that? Like, if you didn't understand, then I'll just explain you. I'll try to explain you one more time. Okay, or whatever it may be. If I'm telling that I'm doing it in 2 operations, then for the second operation, if my initial difference was, let's say, okay, if the initial difference was 4, then if the initial difference was just 3, there was 6 ones. Then what I can do, I can write an alternating string. So 3, 3 equal, and then 3 ones, the 3 extra ones. And in the second operation, I change this 1 to 0, it would become alternating. So you can do it in 2 operations like this. Okay. And even if the difference was 2, okay, so 2 extra ones would be there. So in that case, you will change this 1 to 0 and make it alternating. Okay. And if the difference was 1, then it is already alternating in first operation. If difference was 1, then this condition would only be satisfied in one operation you can do. So if the difference is 2 or 3, okay, so if this absolute value, this difference is 2 or 3, okay, so if it is less than 1, answer is 1. If this difference is 2 or 3, okay, so then in after first shuffling, you can make it like this, and the 3 extra ones, you'll place it at the end and replace one of them by 0, make it alternative. Or if there are 2 extra ones, replace one of them by 0, make it alternative. So when the absolute difference is 2 or 3, you can do it in 2 operations only. Okay. And in the else case, when the absolute difference is greater than 3, then you'll say you'll require at least 3 operations. Because if you want to do it in 2 operations, you just cannot do it. Like if this C1 was 7, so 0, 1, 0, 1, 0, 1, and then 4 times 1 is coming. So this thing you just cannot make it alternating. Or even if you do 1, 0, 1, 0, 1, 0, and 4 times 1. So this need to be changed to 0 and this need to be changed to 0. So, but if you select this substring, this would also get changed to 0. Okay, so I hope you understand why if the absolute difference between zeros and ones is more than 3, if that is more than 3, then your answer is 3. Okay, and in 3 operations, as I explained, there is one way to always do it in 3 operations. If you do something like that, change it to like this, convert, make the zeros and ones equal, and then shuffle again. So in 3 operations, you can always do. Okay, so I hope it is clear. We'll just move to the code and see what all cases we are making. Okay, so what I'm trying to say is, first of all, just check if the string is alternating. Okay, so if the string is already alternating, your answer is 0. So if any of the 2 consecutive characters are equal, then it is not alternating. If it is not the case, then it is alternating. We'll see out 0 and return out. Okay, so this first case is done. Then if the absolute difference between C0 and C1 is less than 1, okay, so the count of 0 and 1 we calculated, if that difference is less than 1, then your answer is 1. Okay, you can do it in one operation, just shuffle them and your job is done. Then if the difference is not 1, if the difference is 2 or 3, okay, so if the difference is less than equal to 3, then your answer is 2. You can do it in 2 operations like this. Okay, 1 0 1 0 1 0, add the extra ones, and in the second operation convert it to 0. Or if the difference is 2, add the extra ones, convert the last one to 0. So this way you can do it in 2 operations. And in the else case, if none of them is satisfied, the difference is more than 3, then you can do it in 3 operations like this. Okay, I hope it is clear to you. Okay, so I think we can move to the next problem now. Or if you have any doubts, you can ask. If you look at the time complexity of this code, this checking part is order of n. And then this count is also taking order of n. And these are just if-else cases. So overall, your time complexity is order of n. And your space complexity is, you are, I think, not using an extra space. The string is of size n, and that's what you are using. So your space complexity is also order of n, you can say. Okay, I think we can move to the next problem now. Okay, so the next problem is multiplexer. So you are given an array A of length n and a positive integer x. You are allowed to perform the following operation at most once. Choose a contiguous subarray of A and multiply each element of the subarray by x. Okay. Your task is to determine the maximum possible frequency of any element in the array after performing the operation at most once. Okay, so basically what this problem states is that you are given an array A. Okay, so you are given an array A of size n, and you are said that you have this operation, that just select any subarray and multiply each element by x. Okay, so you are given an integer x also as an input. So what you can do is select any of the subarray and multiply each of the elements by x. Okay, so all these elements would be multiplied by x. After that, and you can perform this operation only once. Okay, so just select any subarray, multiply all elements by x. Okay, once you are done with that operation, then check in this final array what is the maximum frequency of any element. Okay, so let's say if this array is 1 0 5 4 2 2 1. Okay, so here if the final array is this, then frequency of 1 is 2 times, frequency of 2 is 2 times, 4 0 1 are occurring 1 time. So maximum frequency is either for 2 it is 2 times, or for 1 it is 2 times. So 2 is the maximum frequency. So you need to maximize this value. You need to perform the operation you need to select such a subarray so that after multiplying by x, the final array that you get should have an element with maximum frequency, and that frequency is what you need to maximize. Okay. So basically you need to maximize the frequency of any one of the element. So how do you do that? Okay, let's say for this test case, you are given n is 5, x is 5, and this array. Okay, so here what you did is in this array, you selected, let's say, this subarray and multiplied them by x. Your final array became 10, 2 multiplied by 5 became 10, 8 into 5, 40, 2 into 5 became 10, and 4 remains 4. So in this final array, the frequency of 10 is 3 times. So your maximum frequency is 3. So your answer was 3. So you can see the answer for this test case was 3, because selecting this subarray was most optimal to get an answer of 3. Okay, just a second. Okay. Hello, am I audible? Sorry for the interruption. We'll just continue. Okay. Uh, okay. So what I was explaining here is for this test case, if you select this subarray and multiply them by x, which is 5, you get this array, which has a frequency of 10 as 3. So this was the maximum frequency of any element that you can obtain by performing the operations in any way. If you like selected this subarray only, let's say you selected only this subarray, then you would get 10 to 8 multiplied by 5, 40, 2 multiplied by 5, 10, and 4. Okay, here frequency of 10 was 2 and 2 and 44, their frequency was 1. So your maximum frequency was only 2. But in this case, you got a maximum frequency of 3. So this was the maximum you can obtain. So your answer was 3 here. Okay. So, so I hope the problem statement is clear to you. Now, how do you do it? Basically, also you can look at the constraints that n was given 2e5. Okay, so you need to do the problem in somewhat order of n only, not more than that. Okay, so one approach that comes to your mind is the first one, that the most brute approach. What would come to your mind? What is the operation that you are performing? It is, you only have to select a subarray. Okay, so you just and you have to perform the operation and then just check the maximum frequency. So the most brute way would be just check for all the subarray. If you from selecting a subarray, it means selecting L and R. Okay, so in order of n square, you can just check for, so you can just go through all the subarrays, and for all the subarrays, if that subarray is multiplied by x, whatever the final array you get, for that check the maximum frequency. Frequency you can compute using a map. You can just uh, take the frequency of every element. That way, like, and then checking the frequency would be order of n again. So n square into n and n log n, you can say. So n cube log n would be the most brute way of doing it. Okay, but obviously that would not work. So you would need to think a little bit that what subarrays would be select, so that what is the final thing that you are maximizing is the frequency of the maximum of an element. Okay, so that element has to be one of the elements from this array only, because if you see, the elements can be up till 1 9. Okay, so whatever is the element having maximum frequency, if that, let's suppose that element is out of this array. Okay, so there would be n elements in this array. Okay, and let's say that element is out of this array. It means after multiplying that by x, you get that element. So if there is some element having, after multiplying that element has a frequency of 3, that means, let's say 8 into 5, 40. Let's say 40 has the maximum frequency, I'm supposing. Then 8 would also have that frequency even if we don't do the operation. So we also have that option, that select an empty subarray in this. Okay. Any contiguous subarray, you can even select an empty subarray, or maybe a subarray not involving 8. So that way, if 8 already had that maximum frequency and then multiplying that by 540 had that maximum, so that won't make sense. That means anyhow, whatever elements are there, either of them would have the maximum frequency. So here 10 already had a frequency of 1. And when this subarray was multiplied by x, these 2's also changed to 10, and it has a frequency of 3. So that means if you iterate through all the elements, so all the distinct elements present in the array, at max there would be n elements. And you suppose, let's say you went to 10. You suppose that if 10 is the final element having maximum frequency, what is the maximum frequency we can give to 10? Okay, how can we maximize the frequency of 10? If you think it like that. So for 10, it already had a frequency of 1. How can we get more 10s in this by applying our operation? For operation, we are given x equal to 5. That means if you have a 2, it would be multiplied by 5 and changed to 10. Okay. So if you have to change your, let's say I'm telling this as y. Okay, if y has the maximum frequency, okay, you will get the frequency for y either y in your original array, or what is the frequency of y in your original array plus the frequency of y divided by x. Okay, so if y was 10, so 10 by 5 is 2. So all the 2's which might get multiplied by 5 and change to 10, frequency of y by x in the selected subarray, you can say. Okay, and frequency of y in original array. Now, if there was 10 in this subarray also, like let's say instead of this 8, there was 10. So in the original array, there were two tens, but after multiplying, this 10 would become 50. So this would no more be a 10. So frequency of y in original array, excluding selected subarray. Okay, so basically, if you have an array and you select some subarray from L to R, if you select some subarray from L to R, then the frequency of y would be frequency of y here plus frequency of y by x here. That's what I have written. I hope this thing is clear to you. So I'm telling that if in your array you have selected a subarray from L to R, then your frequency or in frequency of y, or basically, yes, the frequency of y in your converted array, basically in your final array, it would be the frequency of y in this region plus this region, okay, plus the frequency of y by upon x. Okay, now this would be exactly y by x, not an integer division. Let's say y is 11 and x is 3. So 11 by 3 is basically 3.6667. So if you're taking it as 3, then 3 multiplied by 3 would give you 9, and 4 multiplied by 3 is going to give you 12. So you would never get 11. So if this y is not divisible by x, then you can just say this free, count this as 0. Okay, so basically you cannot get any 11 by multiplying by 3, any element by multiplying by 3. So there is no use of selecting a subarray and increasing its frequency. Whatever is the frequency of 11 in the original array, it would remain that only. Okay, so if it is divisible, then only I'm counting this case. So frequency of y in the remaining, excluding L to R, in these two regions, what is the frequency of y plus I'm telling the frequency of y upon x in this region. Okay, so that is what would be the frequency of y in your final answer. So if you iterate through all the y, like all the basically all the numbers present in the array, then for that y, you just need to check the indexes where there is some y or there is some y by x. So for any y, there are two numbers, y and y by x. Okay, so what you can do is in a map, you can, for every element, you can store a map that what are the indexes where this element is present. Okay, like for this array, you can convert this array like this, that where is 10 present? 10 is present at, let's say I'm taking 0 based indexing. 10 is present at index 0. 2 is present at index 1 and 3. 1 and 3. At both position 1 and 3, 2 is present. Okay. Then 8 is present at index 2 and 4 is present at index 4. So you can convert this array in this form, that for every value, what are the positions where they are stored. Okay. Now from this, if you iterate through all the values, so for 10, you would have 10 and 10 by 5, 2. Okay. So you only need to see these two. You only need to check the positions of uh, these two indexes, basically, all these. So if you just basically consider a vector having these indexes only, in that you just need to divide from them what subarray you take so that you maximize this thing. Okay, so that you maximize this thing. So if I'm telling there was a 10 here, okay, so or there was a y here, a y here, a y here, a y here, and there was a y by x here, y by x here, and y by x here. Okay, so this element and this element was something different. So just ignore them. Only consider those indexes where there was either y or y by x. Now, for the new array that you form just by considering these indexes, in that also you can do a partitioning of L to R. So you need to find the most optimal subarray in that, so that this all the y excluding the subarray, you will count y's. Okay, so 1, 2, 3, and inside the subarray you would count y by x, 1, 2. So 3 plus 2, you will get 5. Okay, so this since this y is inside the subarray, it would get excluded. And since this y by x is outside subarray, it would get excluded. And you would count this, and this. Okay. But if the partitioning was something like this, okay, instead of selecting this as L and R, let's say you selected this and this as your L and R, then what would happen? This would be selected, this y by x is inside, so selected. This y is inside, so not selected. Y by x is inside, selected. This would also get selected. This would also get selected. You will have 1, 2, 3, 4, 5, 6 as your answer. So this was more optimal. Now, how do you find this basically? That which is the most optimal subarray you select, so that inside the subarray, if you're counting y by x, and outside if you're counting y, then that thing is maximized. Okay, so if you can somehow do it in order of, okay, what is the complexity you would get, or what is your required complexity? So if you have converted it in this fashion, then for every value you have some indexes. Okay, so for every value, if you're checking for two vectors, okay, then when you go to every value, at max what would happen? For 10, you are checking for 10 and 2. For maybe there was some 20 for which we were checking for 20 and 4. Okay, so at max, how many times would you check 2? These indexes, how many times would you check? For 2 you would check, and for 10 you would check 2 times. Okay, so at max all the indexes would be checked 2 times. So basically, if you do it in the order of the size of this vector, okay, so for 10, if you calculate it, whatever is the size of wherever, basically for 10, if you calculated these 3, okay, wherever there is 10, wherever there is 2, if you only consider those positions, and in that order if you compute your answer, then overall complexity would be order of n only. Order of 2n it would be. 2n is same as n. Okay, so I hope you understand that thing. So for every value, when you store this map, okay, and then for every value, you only need to check the vectors of y and y by x. Okay, only those positions. So if you just check only those position and form a new vector from values of only those positions, then basically in order of that, in O of size of that new vector, if you can compute the most optimal answer, you can do it in the required time complexity. How can you compute the most optimal subarray? For that, what you can do, you can consider it like that, like this. For this subarray, let's say, okay, wherever there is a y, let's say you write a -1 here. Okay, and then again you get a y, you write a -1. You get a y by x, you write a +1. You write a y, for a y, you write -1. For y by x, you write +1, +1, and -1. If you make a new vector like this, for every y, you add a +1. For every for every y, you add a -1. For every y by x, you add a +1. So whenever you do a partition from L to R, then before L, you would count all the minus ones. Okay, like what you need to do is, if you don't do any partition, okay, then in overall answer, what is the frequency? Wherever you have the y, okay, wherever you have the count of y is your final frequency, 1, 2, 3, 4. But by selecting a subarray, you may be ignoring some y, but you are including some y by x. So for y by x, I'm taking that as +1. So whenever you select a subarray, in that y by x is a +1 to your frequency and y is a -1 to your overall frequency. So if you take this as +1, -1, +1, -1, then what you need to do now? You need to select a subarray so that it has the maximum sum. For that subarray, whatever is the sum of +1, -1, +1, okay, this sum was +3, -1, 2. That means you're increasing your frequency by 2. Whatever was your original frequency of y, that was 4 here. By selecting this subarray, you increase the frequency from 4 to 6. Why? Because you're selecting the most optimal subarray, which is going to, you're converting that into the net. Basically, for y, you are taking it as -1. For y by x, you are taking +1. So all those values that come inside the subarray, if you count their +1, -1, the maximum subarray sum that you get, that is what is the maximum you can increase your frequency of y with. And how do you get the maximum subarray sum in an array? Maybe you know an algorithm for that, which is known as the Kadani's algorithm. That if you are given an array, okay, so if you are given this array, you need to find a subarray having maximum sum. So there's a standard algorithm for that, which is Kadani's algorithm, which is very simple. You just start with the first element, maintain a sum. Let's say it is 0 and a maximum sum, the subarray sum that you get. Okay, when you go to the first element, update your sum, -1, it becomes -1. If your overall sum becomes less than 0, then again convert it to 0. Okay, again you got -1, make it -1, it became less, make it 0 again. With a +1, if it is more than 0, let it be like that. Okay, and keep on maximizing it with your mx variable. Okay, so that way, if your answer is going below 0, then you are moving your L there so that it becomes 0. You are excluding the previous part. Again, you are summing up. If your answer becomes below 0, you are taking your L there. That way you can find the maximum subarray sum. Okay, I hope you know that. So this way, you can just solve the entire problem in the optimal time complexity. Okay, I hope the logic is clear to you. So I'll one more time write the whole logic in a more cleaner way. So whatever, yeah, you can ask.
So, for each of the number in the given array, which is O of n, we are also checking for the optimal subarray, which is also in the order of n. So it will be n square and it should give a TL,
Okay, that's what
or what
I
I'm
was trying to explain. Okay, I'll explain that what I'm doing. So whatever array you are given, let's say it was something like 10, 2, 10, 5, 2, 2, 6, 10. Okay. For that, first you converted this array, whatever array you were given, in the form of, for every element, what is their index. Okay, in a map, okay, these are the indexes. You took a map of basically int comma vector. Okay, that is the data structure that you are going to use. And in that, you'll just go to every element, do a map of AI plus plus. This way, what you would get finally, 10, map of AI dot pushback, like, okay, for every element, I'm not writing the code, I showed it there. For every element, 10. So in your map of 10, I'll push back 0. So in the it would have 0. And then when you get 2, for 2, I'll get 1. For 10 again, so in here you got this 2. So basically what it would form, all the indexes where 10 is present. So 0, 2, and 7. So 0 to 7. This map of 10 would store a vector containing the positions of 10. Okay, map of 2 would store a vector containing the positions of 2, which is 1, 4, and 5. So 1, 4, and 5 would be the positions of 2. What is the positions of 5? It is 3 only. And what are the positions of 6 and 10? For 6, it is 6, and for 10, it is 7. Okay, so whatever input array you are given, first you converted in this form. Okay, and then what I'm telling now, in this form, you know, for every value, for a value 10, what are the positions where 10 is present? For value 2, what are the positions where 2 is present? Now when I go to 10, okay, then I would check for 10 and 10 by x. Okay, I'll check for 10 and 10 by x, which is 2. Okay, I'm taking x equal to 5 here, then 2. So for 10, I'll construct a new array having only the positions of 10 and 2. So this combined would be like 3 here and 3 here, a new vector of size 6. Okay, and in that I'll compute in order of 6. Okay, then when I go to 2, I'll check for 2 and 2 by x. Okay, so uh, I'll use this vector and some other vector, which is 2 by x. For 5, I'll use 5 and 5 by x, some other 5 by x. Okay, whatever is 1. So if you see every like the vector, this vector, how many times this vector is being used? It is used when you're calculating for 2 and when you're calculating for 10. So at max, all the positions would be used 2 times. So overall, if I'm doing for 10, if I'm doing in order of 3 plus 3, 6. For 2, I'm doing in order of 3 plus the frequency of 2 by 5 is 0. So that is order of 3 only. For 5, I'm doing in order of 5, and 5 by 5 is 1. So 1, the vector is empty. You can consider if it's not in the map. So this is done in order of 1. This is done in order of 6. Order of 1. This is done in order of 1. This in order of 3. This in order of 6. Okay. So overall, if you sum them up, it would be 2n at max. For every position that would be used at max 2 times. Okay, so in this array, if you just divide this array into smaller arrays containing indexes of 10, okay, this is one partition, indexes of 2 is one partition, indexes of 5 is one partition. So this complete array is partitioned into the smaller arrays containing the same values. Okay, so and you are doing it you are using every array 2 times only. So overall, the sum of all of this for all the values, if you are applying that algorithm and doing it in the order of that, then it is basically the sum of these smaller vectors, which are used at max 2 times. So overall complexity would be O of 2n only. Is it clear to you now?
Yes, sir. Got it. Thank you.
Okay. So I hope this logic is clear to you. First, I'm converting it into something like this. And then when I'm checking for 10, I'll take y as 10 and this y by x as 2. So I'll form a new vector using only indexes of these two, 10 and 2. So I would just merge these two. So how would I merge these two? So I'll form a new vector. So basically in this array, now these positions would be in sorted way. So first I will see among 0 and 1, 1 is 0 is smaller. So first this 10 would be there. So I'm basically forming a new array. For 10, I would have a +1. For 2, I would have or basically for 10, I would have a -1. For 2, I would have a +1. So at index 0, I got a 10. So I wrote a -1. Then at index 1, I got a 2. I wrote a +1. Then index 2, I got a 10. I wrote a -1. Then 3 is not there. The next smallest index we have is 4. So for 4, we have a 2, which is +1. Then the next smallest is 5, +1. Next smallest is 7. So -1. So this way, when we merge these two vectors and whenever you get an index of 2, you add a +1, an index of 10, you get add a -1. That way, in this merged vector, you apply Kadani's algorithm to find the maximum subarray sum. And then whatever is the maximum subarray sum, if that is mx, your frequency of 10, the maximum frequency of 10 is frequency of 10 in the original array, which is whatever is the size of this vector, it was 3. So size of that vector plus whatever you got from the Kadani's algorithm. That would be the frequency of 10, the maximum frequency of 10 you can get. You would maximize this for every value. Okay. So I hope this logic is clear to you. We'll move on to the code now. Okay, so first we take the input here. Okay, now one special case we needed to consider here was for x equal to 1. Okay, so if this x can also be 1. So for x equal to 1, multiplying by 1 doesn't change the answer. So in that, your y and y by x would be same. So if you are applying that algorithm, you may get some wrong answer. So just handle the case of 1 separately. For all the other values of x greater than 1, all the values in the range which are y. Okay, so like what would happen for 1? Okay, so if your x is 1, then whatever subarray you consider, that multiplied by 1 would remain same. But if your x is greater than 1, then whatever subarray you consider, inside the subarray, all the y would get multiplied by x and become not equal to y. Okay, and all the y by x would become equal to y. So if x was 1, your logic that inside the subarray, all your y would not be y now. You're taking -1 there, that fails because even after multiplying by 1, that y remains 1. So just handle that x equal to 1 case separately. For all the values greater than 1, your logic as explained above would work. So it's very simple to handle the x equal to 1 case. Applying the operation means nothing. So in the original array only, just count whichever element has the maximum frequency. That frequency is your answer. So just count the frequency of all the elements and take the maximum. So for x equal to 1, I simply created a map and counted the frequency like this for every value f of ai plus plus. And then I went to the map and the maximum p dot ss is second. So in the map, whichever frequency was maximum, that's my final answer. So x equal to 1 case is done, I returned out. Now, if x is not 1, then I apply the logic as said above. I take a map of int comma vector int. Okay, so for every value, I'll in the map of that value that contains a vector. So in that vector, I push back that index I. Okay, so if I'm doing like this way, I'm able to create from this array, I'm able to create this map. Okay, when I move to 10, in 10, I'll push back 0. When I move to 2, in 2, I'll push back 1. When I move to 10, in 10, I'll push back 2. Okay, so this way, this whole thing would be created. Okay, so once this is done, now I'll iterate through every value in my map. Okay, so y comma x, the value is the y that I'm considering, and this v is the vector representing the positions where y is there in the original array. Okay, so f is initially my frequency is v dot size. Okay, whatever is the size of that vector, that is the number of positions where we have that is the frequency of that in original array. Okay, so size of v is the frequency of y in my original array. That's what I'm storing. So this at minimum we will get this. Now I'm trying to increase this frequency using by selecting a subarray and using Kadani's algorithm. Whatever I'll get, I'll increase, I'll add that, and that would be my answer. Now first is if y is not divisible by x. So a y by x would not exist. So there is no need to do that. Simply f would be my answer in that case. Okay, so I'll maximize it with my overall answer and continue. Okay, if there is no y by x, there is no point of selecting a subarray and trying to maximize anything. Okay, so if y is not divisible, then just take it and continue. Okay, so if y is divisible by x, Then map of y by x is your second vector. Okay. So now we are going to merge this vector v and this second vector v2. Okay. Merge both of them using a -1 + 1 technique. Okay. So how are we going to merge them? I take two variables I and j and this vector vec where I'm going to merge them up. Okay. And then I'll just check while I I mean I is a pointer for the first vector and j is the pointer for the second vector. Okay, so if vi is less than vj, okay, whichever is index is less, so that means I'm pushing back from the first vector. For original for y, for the positions of y, I'll push back -1. And if v2j is greater, is smaller, then I'll push back 1. That means I'm pushing back from y by x vector. Okay, so if I'm pushing back here, then I'll do j plus plus. So here I'll do I plus plus. This way, and then if one of the pointers moves to the end, then it may be the second pointer is still not at the end. So I'll write these two while loops also. If I has not reached the end, then just push back -1 until it reaches there. If j has not reached the end, then just push back 1. Okay, so I hope this is like, if you have studied the merge sort technique, there also this type of thing is used where you are merging two arrays in a sorted order. So that's what this technique is. After that, I'm using a Cardano's algorithm here. Okay, I take a mx and an s, and then in sum I sum plus equal to vec of I. If sum becomes less than 0, I make it 0 again, and my maximize my overall sum. Okay, so whatever maximum sum I get, I'll add that to f. That is the maximum frequency I can obtain for that value and maximize it with my overall answer. Okay, and that's my final answer. I hope the code is also clear to you. So as I explained before, only the time complexity of this code, overall this like inside the for loop, whatever I'm doing, that is of order of the size of v1 plus v2. Okay, so inside all these things, this while loop and all is done, that overall thing is order of size of v1 plus size of v2 or v plus v2. This is for one loop, and the size of v overall for all the n, sum of the size of v is n, and sum of the size of v2 is n. Okay, so your overall complexity is order of n only here for this for loop. Okay, so and this inserting in a map would take n log n time. So this is n, and this insert is taking log n time. So this overall thing would take n log n time. So your overall time complexity for the code would be order of n log n. Okay, and the space complexity would be, okay, I think you are using just an array of size n, and this map would, the size of this map would also be n, because n times n elements are only pushed into the map. So overall space complexity is order of n. Okay, I hope this problem is clear to you. So we can move on to the next problem. Okay, so the last problem that we are going to discuss today is the skip game. Okay, so here what you are given is, you are given n cards numbered from 1 to n, and there are n players who are also numbered from 1 to n. The players are playing a deck-based game which follows two key sequences. Permutation A decides the order in which players take turn. Permutation B represents the order of the deck of cards. Okay. The game is played like this. The player take turns sequentially in order given by A. Okay, so A gives the order in which the players take turn, and B gives the order in which the deck is arranged. So the deck has n cards numbered from 1 to n, and there are n players numbered from 1 to n. So array A represents the order in which players take turn, and okay, B represents the deck. So in the ith turn, if the ith player is taking ith player is taking the turn, then he would either skip. Okay, so he would check what is the topmost card in the deck. If that is equal to AI, the player would skip the turn. And if the topmost card is not equal to AI, then he would remove the topmost card. Okay. Now, each player takes exactly one turn, and after all and players take their turn, FAB represents the total number of skipped moves. So after all those n terms, the number of moves that are skipped, that is what FAB represents. So for a given permutation of turns, given A and a given B, a given permutation of deck of cards, you know how many times this turn would be skipped, and that is what we are calling F of AB. Some positions in A are already fixed, meaning they are assigned. So now you are given array A in the form that some values are already given to you and some values are assigned -1. So that -1 can be filled up by you using any of the remaining values so that A becomes a permutation. And B also you can take in any way. Now you just need to count how many valid pairs AB are there so that the K given to you is F of AB is equal to K. Okay. Answer may be large. So you just need to find number of ways so that F of AB is equal to A, number of ways of forming the permutations A and B. Okay, so like I'll explain the problem once. So you are given an permutation A of size n, something like that. Like 1, 2, 3, 4 are there, 5, 6 are missing, and there are two -1s. So you can replace these -1s by 5, 6 like this, or you may replace it with 5, 6 like this. So you can do any possible replacements. And then, okay, this is what you are given, and you are given a K. Okay. So you need to find you can take any array B. Okay. Array B is completely up to you. So you just need to find number of ways of taking A and B so that so that your F of AB is equal to K. So F of AB is, this is the order of players taking turns and B is the order of deck of cards. Okay, so what does that mean? Let's say A is 1, 3, 2. B is 2, 3, 1. Okay, so what would happen? How the game would proceed? The first player is player 1. He would see the top of the deck is 2. So deck is like that. So 2 is at the top, then 3, then 1. He would say the top of the deck is 2 and this player 1 is taking turn. So 2 is not equal to 1. He would remove the card 2. Okay. Then player 3 would come. He would check the top of the deck. 3 is equal to 3. The top of the deck is same. So he would not remove this card. So there is +1 to the number of skipped turn. His turn would be skipped. Now player 2 comes. He would see the top of the deck is 3, which is not same as 2. So he would remove that card and go. So how many turns got skipped? Only one turn got skipped. So if your K was 1, then this AB was a valid AB. Now you need to count how many such valid AB exist so that number of skip moved is K. Okay, I hope the problem statement is clear too. Now, how do we solve this problem? Okay, so like it was more of a combinatorial problem only, just you need to count the number of ways in optimal way. So if you check the constraints, then n is 2e5. So you need to do it some order of n only. Okay. Final answer has to be printed in modulo 1e9 plus 7. Okay, so let's try to derive some formula for this. Okay, so first thing is you are given this array A like this. So wherever there is some -1, so if there are two -1s, what is the number of ways to replace them? So what is the number of different A's that you get? So if there are two -1, either replace it with 5, 6 or 6, 5. So if there are C number of -1 in the original array, then there would be C factorial number of ways of A. Okay. And for every way, okay, so first of all, there are C factorial number of ways of A. And for a fixed A, now once you replace this with, let's say, 5 and 6, now this A is fixed. When A is fixed, how many valid B exist so that F of AB is equal to K is what you need to count. Okay. So what all would be the valid Bs if you analyze this operations carefully? So if I'm telling there are three of the moves which are getting skipped. Okay, let's see when does a move get skipped. Initially, one would come to two. If they are unequal, that is removed. Okay, one gets to two. Then three gets to three. If they are equal, then the turn is skipped. So first of all, for A and B, the first one would move to first. If they are unequal, removed. Second would move to second, unequal, removed. Third would move to third, unequal, removed. The first time when the ith one moves to ith and that is not removed, it means whenever AI is equal to BI, the first position where AI is equal to BI, there the game would change a little. Before that, every ith would go to ith, and if they are unequal, 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 removed, not removed, 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 removed. Okay. When they got equal the first time, after that it is not removed. So if this was I, then what would happen to I plus 1th person? This is not removed. So this would be the deck he would be checking. So next he would be, I plus 1 would be checking the ith deck, ith card on the deck. If it is unequal, removed. Now, you know, these were equal. AI was equal to BI and it is not removed. So definitely AI plus 1 would not be equal to BI, because since it is a permutation, these two elements cannot be same. So if this element was equal to this element, then these two are unequal for sure. Okay, so whenever you get some equality, the next one, this has to be unequal for sure, and this would be removed. Okay, then this would be checked with this. So I plus 1 would be checked with I plus 2. If it is unequal, remove and check like this. Okay, so until, let's say, this is equal to this again. So at some index j again, at j and j plus 1, these two values become equal. So this would not be removed, and then it checking would go on like this. Okay, so what I'm telling is, for the array A and B, checking is something like this: equal, 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 one unequal, then checking like continues like this. I with I plus 1, I with I plus 1, and then again, if they become equal, then checking continues like this: with I plus 2, I plus 2, I plus 2. If they become equal, then checking continues with I plus 3, I plus 3, I plus 3. Okay, so this is how checking would be. So if I'm telling that there are three skips, that means three times you will get equal. So the first time where AI is equal to BI, next time where AI plus 1 is equal to BI, next where AI plus 2 is equal to BI. There are three different, then there would be three skips. Okay. So in order to get k number of skips, what you can say, how many valid B exist? You know, A is fixed. Okay. A is fixed. You need to count how many valid B exist so that you get k number of skips. That means what you need, first of all, in this array A, you select three indices which you would make equal, and basically you say you select three players who are going to skip. Okay, so among these n indices, you select k indices which are going to get skipped. Okay, let's say you're selected this, this, and this, some of the three which are getting skipped. Now you cannot select two consecutive indices to get skipped, because you know, if this is getting skipped, this one is not going to get skipped for sure. This may get skipped. Okay, so you need to select among these n values, you need to select k values such that they are not consecutive. Any of the two values are not consecutive, first of all. Okay, so among these n values, first thing is select k values among n values, or I can say k non-consecutive values. So First, select k non-consecutive values among n values. Now, once you have selected the k non-consecutive values, now you have fixed that these are the three values that are going to get skipped. These are the three persons who are going to skip their turn, and all the remaining persons are not going to skip their turn. So how should your B look like? For this condition, how should your B look like? So if these three indexes are, let's say, I1, I2, and I3, okay, then in your array B, this I1 index should be equal to A of I1. This I2 minus 1 should be equal to I2. And this I3 minus 2, okay, somewhere like this. This I3 minus 2 is equal to I3. And rest of the values should be unequal. So this is your condition that now in your array A, once you have fixed the three values, I1, I2, I3, you have fixed the values of B in these three positions, in I1, I1 minus 1, and I3 minus 3. These three values are fixed. For the remaining values, okay, for the remaining n minus k values, you can have any arrangement so that this is not equal, 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 this is not equal. Now, this condition that I1 plus 1 and I1, they are not equal, that is already satisfied because these are equal. So this is not a restriction. Only restrictions you have is this, 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 this. This is not a restriction. This are restrictions. Okay. So how many? So now you can see the number of ways to do this is like a D arrangement. Okay. You need to form a permutation. Exclude these three values are already done. So you need to form a permutation of n minus k values. So among n, k values are already fixed. So for the remaining n minus k values, you need to permute them so that it satisfies some D arrangement, that this, for the first value, you have a restriction that it should not be equal to this. It can be anything else. For this, it should not be equal to this. Now, what do we do in a D arrangement? Okay, we'll come to that. How do we find the number of ways to permute these n minus k values? Now, here there are not n minus k restrictions, but for every this restriction, there is a one value which is not enforcing a restrictions. So there is n minus 2k restrictions only, not exactly n minus k restrictions. Okay. So for n minus k values with n minus 2k restrictions, how many exist? If you can calculate that count, then that multiplied by, if you can calculate the number of ways to select k non-consecutive elements from n values, the product of them is going to give you the number of b's that exist for a fixed A. And that multiplied by c factorial, this c factorial number of ways of A is going to give your final answer. I hope it is clear to you, this thing. Now we need to compute two things. Okay, so what I told is my final answer is c factorial number of different ways to select A. For a given A, if A is a given permutation, for all of them, the number of ways to select B would be same. If you need to have K, f of AB is equal to K. Why? I think that thing is kind of clear because A is some permutation, and then what value is where, that doesn't matter. Like if you look at the symmetry of the problem, you can just imagine that it doesn't matter for different permutations, your answer would be same only. If your K is fixed, the number of ways of selecting B would be same. Okay, so this multiplied by number of ways of selecting B. Number of ways of selecting B is in array A fix k elements. Okay, so for that it would be select k non-consecutive values. If this thing I'm telling as F1, and after selecting that, among the remaining n minus k places in B with n minus 2k restrictions, how many ways are there to select a valid B? If that thing I'm telling as F2, then answer is that F1 into F2. Okay, this is your final answer. But how do you calculate this F1 and F2? Let's discuss that. First is, how do you select k non-consecutive elements among n values? Okay, so if you have n values, in that you need to select, if you in n values, if you need to select k values, what are the number of ways? N, C, K, simple. But here in this k values, it can be that you selected this, this, and this. So there are two consecutive values. So this is not valid. You need to select k non-consecutive values in n elements. So what we can say is, let's say you are selecting this, this, and this. Let's say k is 3. You are selecting these 3 values, something like that. That means whenever you're selecting 3 values, you are dividing this. If you look at the unselected values, you are dividing these n values into 3 parts. This is one part, second part, third part, fourth part. So selecting k values means dividing the array into k plus 1 parts. Okay. And among these k plus 1 parts, since you need to make sure that these two elements are non-consecutive, this part should have a length greater than 1, greater than equal to 1. It cannot have a length of 0. If there is nothing here, then these two would come together and they would become consecutive. So if you just fix the length of these 4 parts, you got your partition. So if I'm telling the length of this part is x1, this is x2, this is x3, this is x4, then what should be the sum of x1 plus x2 plus x3 plus x4? That should be equal to, in this n values, k values already selected. So n minus k. Okay, k was 3 here, let's say. So it's n minus k. So number of ways of writing these x1, x2, x3, x4 so that their sum is equal to n minus k, such that with the given condition that this x2 and x3 should be greater than equal to 1, so that they are non-consecutive. But this x1 and x4 can be 0 also. If this is the first element which is selected, then there is nothing to the left. So the middle values, they have a restriction, they should be greater than equal to 1, but these values should just be greater than equal to 0. Now, you know the formula, I think, or the number of ways. If you are given something like this, x1 plus x2 plus x3 plus xr equal to n, the number of ways of writing this so all these values are greater than equal to 0 is n plus r minus 1 cr, n plus r minus 1 cr. I think it's that only, or cr minus 1. Yeah, n plus r minus 1 cr minus 1. Now here you are given the here it is of the form that x1 plus x2 plus xk plus 1 is equal to n minus k plus xk plus x, such that these values are greater than equal to 1 and these values are greater than equal to 0. Now this formula is valid when all these values are greater than equal to 0. So how do you convert this thing to all these values greater than equal to 0? For all these value, you do a minus 1, let's say. Okay. So there are k minus 1 values. You take a variable x2 dash, which is x2 minus 1. So then you can write x1 plus x2 dash plus x3 dash plus xk dash plus xk plus 1. This thing should be equal to n minus k. No, x2 dash is x2 minus 1. So there is minus 1 here. When it goes to the right, so you are replacing x2 with x2 dash. So basically x2 is x2 dash plus 1. Okay. So there is this plus 1, plus 1, plus 1, plus 1. So how many plus are there? Plus k minus 1 plus are there. When it goes to the right, it becomes minus k minus 1. Okay. So that means it is equal to n minus 2k plus 1. So x1 plus x2 dash plus xk dash plus xk plus 1 is equal to this, where all these variables are greater than equal to 0. Then you can apply this formula. So in this, your n is this, k is this. So this formula is going to give you this is n plus this r minus 1 c r minus 1. Okay. What is this? This is, if you look, this is n minus k uh, plus 1 plus 2 minus 1 plus 1 ck. Okay. So you derive the formula that this is the number of ways to select k non-consecutive elements among n elements. So your F1 is this. Now, how do you calculate F2? Okay, let's look at this. So if you know how to calculate the number of D arrangement, it is somewhat similar to that. Okay. So you have here we would look to find a function. Okay, let's try to find the answer for a function. Okay, then we'll convert to the original. Let's say you have you need to find the permutation of size n. Okay, you need to find a permutation of size n with k restrictions of the form that this. Okay, there are some k restrictions that these should be unequal to some value. Okay, so these k restrictions are there and there are some unrestricted values only. You can place anything from that. So if they or there are n restrictions in that, then that is what the number of D arrangements is there, which the formula for that is n factorial upon 1 minus n factorial by 2 plus n factorial by 3 minus n factorial by 4. I hope you know this formula of number of D arrangements, but how that is derived? Okay, but that is when number of restrictions are also n. Here the number of restrictions are k. So we'll try to figure out when number of restrictions are k, how can we change this? So how that number of D arrangement thing was derived, that if you consider n factorial is the total number of arrangements of this A. Among them, subtract all those arrangements where some of these restrictions are getting invalidated. Okay, some of these restrictions are broken. So from that, first select if only if more than one restriction is broken. Okay, so among these k restrictions, let's select any one restriction. Okay, among this k, restrict any one. Okay, any one restriction. I'm telling this restriction is broken. That means in this value, whatever is the value of bi, that is only put. Okay, yeah, here these two became equal. So whatever is there in bi, that is only put. So then among the remaining, whatever is your number of arrangements of remaining. Okay, so n minus 1 factorial. Okay, so if you select n factorial is all the combinations minus where one restriction is broken. At least one restriction is broken, one or more than one. Okay, if you have subtracted that, then when there are two restrictions broken, you need to add like from all the permutations, all those where at least one restriction, one or more than one restriction is broken, that is subtracted. So when two or more than two restriction is broken, that need to be added. So kc2 into n minus 2 factorial, and then from that, when at least three restriction is broken, that need to be subtracted. So I hope so. This way it would go on. So basically I can write the number of ways is, and this can be written as nc kc0 like plus. Okay, so kc, you can write m summation from m equal to 0 up till k kcm into n minus m factorial with a sign of, okay, so when m is 0, 2, in that case you get a plus sign. When m is odd, you get a minus sign. So minus 1 to the power m, you can say. Okay. So like when m is, so this summation is what you can tell is number of like dearrangements with k restrictions. Okay, so you have got this formula. Now, how do you combine this? Now, it's not exactly what F2 is. Okay. Now, if you look at the original problem, in your original problem, there are k values that are fixed. Okay. And among the remaining n minus k values, they are posing some restrictions. It's not exactly n minus 2k restrictions. You will see how. So let's say in your array A, some of these values are selected. Okay, you have an array of size. Let's say these values are selected. 1, 2, 3, 4, 5, 6, 7, 8. N is 8, K is 3. Okay. And in your array B, so for your array B, whatever is value is there, that has to be here. So like A1 would, okay. So in how many number of B exist if you need to find that? Okay, so you have selected these three. Okay, you have fixed. So first of all, you will apply this thing, number of ways to select k non-consecutive elements. Okay, so these are the number of ways. Once you have selected k non-consecutive elements, so let's say these three non-consecutive elements are selected. So there your turn would be skipped. So it means these two should be equal. Okay, so these two should be equal. So here it should be A1. Okay, and then this would be compared with this would be compared with this, and then these two should be equal. So this should be equal to A3. Okay, and then again it is compared to this is compared to this would be unequal, and when this is compared to this, they are equal. So here you have A6. Okay, then this is compared to this compared to, okay, 1, 2, 3, 4, 5, 6, and 7. This compared to this, and these three are not compared to anyone. Okay, so finally, if you look, three values are already fixed, and for the remaining 1, 2, 3, 4, 5 values, basically for the remaining n minus k values, there are 1 and 2 restrictions. Okay, this is not question any restriction. No, and there are 2 restrictions. So how many restrictions are there? This for every selected element, it is going to fix a value and make another value not do a restriction, because this restriction is not counted here. This value is already fixed and it would be unequal for sure. So it is going to fix a value and make a value not be restricted. Fix a value and make the value to the right not be restricted. So there would be n minus 2k restrictions for the n minus k values. Okay. So you need to find number of arrangements for n minus k values with n minus 2k restrictions. But there is one special case. If this last value, if let's suppose in A, the last value 1, 2, 3, 4, 5, 6, 7, 8. If the three selected elements were somewhere like these, okay. So to the right of this, there is nothing. So subtracting a one restriction that this was not posted. Okay, like here you can see this n minus k was 8 minus 3 equal to 5. So this is 1, 2, 3, 4, 5 values that you values that are going to get rearranged. You need to find a permutation for these 5 values with restrictions, with how many restrictions? N minus 2k. 8 minus 6, 2 restrictions. So this is one restriction and this is one restriction. Okay, so like this is not a valid restriction, not a valid restriction, not a valid restriction. So among those n minus k values, 3 of the restrictions are not valid. So n minus 2k, 2 restrictions are valid. But if it is something like this, then 1, 2, 3, 4, 5, 6, 7, 8, you would have this fixed value, this fixed value, and this fixed value. So this restriction would not be valid. This restriction would not be valid. And this restriction not valid doesn't mean anything because there is nothing. So you have this restriction, this restriction, and this restriction. A total of 3 restrictions you got, not 2. So if you're selected, there is the last value selected, then you are going to get n minus 2k plus 1 restrictions. Okay. So if this thing is what I'm calling as func of n minus k, so your f2 would be func of n minus k comma n minus 2k. You need to find the number of permutations of n minus k values with n minus 2k restrictions. Okay, this was giving you number of permutation of n values with k restrictions. So here you have n minus k values with n minus 2k restrictions. Normally it would be this if last element is not selected, and it would be the func of n minus k comma n minus 2k plus 1 otherwise. That's what you can call f2 as. Okay, so basically f1 also need to get divided into the 2 cases where last element is selected or not selected. So I'll say basically the number of ways of selecting the k elements. Okay, that's what I was telling as f1. The number of ways to select k non-consecutive elements. So it would have 2 cases. If the last element is selected, then I'll say the last element is selected, and among those n minus 1 values, I have to, so this cannot be selected if last is selected. So among those n minus 2 values, I have to select k minus 1. 1 is already selected. So this, so if last element, like if I'm telling this function, let's name this function also something. Okay, it's not exactly f1. Let's say this function is number of what I'm doing here. I'm selecting the k values, selecting k non-consecutive values. Let's say this is select n comma k. Okay, so among n values, if I have to select k non-consecutive values, this is what is the number of ways. So here I would say select. If I have to, it is fixed that I have to select the last element, then among the remaining n minus 2 elements, I have to select k minus 1. Or if it is fixed that I have to not select the last element, then among the remaining n minus, so if I have to not select the last element, so among the remaining n minus 1 element, I have to select k elements. So among the remaining n minus 1, I have to select k elements. So my final answer is f1 plus f2 case wise. Okay, so this was for the case if last element is selected and this is otherwise. Okay, so I can say my final answer is, okay, c factorial multiplied by case 1 if last element is selected. So if last element is selected, if last element is selected, f1 is this, f2 is this. So multiply both of them. So this multiplied by this. Okay, select n minus 2 k minus 1 multiplied by func n minus k n minus 2k plus 1. So if last element is selected, or the other cases, we'll add the 2 cases. If last element is not selected, then this is for f1, this is for f2. Okay, just write that one. Okay, I hope it is clear. So this is my final answer. Okay. I have to just write these two functions of select and func. What are these functions? Func is this summation, which can be computed in order of k. Okay. So this func can be calculated in order of k, and select is this function which can be calculated in order of 1 if you have pre-computed those factorials. Okay. So I'll pre-compute the factorials, then this NCR can be calculated in order of 1, and this can also be calculated in order of k times these values are getting added. So in overall order of k, I am able to do this. Okay, if you look at the constraints, k was less than n, which is 25. So I hope this problem is clear to you. I will move to the code now. So first I made these two functions. First, what I did is pre-computed my factorials. So I'll show that. Okay, here I have just pre-computed my factorials, and I have pre-computed NCR. Okay, mod m. I have to do everything in mod m. Okay, mod 1e9 plus 7. M is 1e9 plus 7. So all the till 1e6, I have pre-computed all the factorials. Till 1e6, you can ignore the inverse factorials. That is not required here. Okay, that is required in NCR. So all the factorials and the inverse factorials. This is a fast way to pre-compute that. So all the factorials mod m is pre-computed. NCR mod m is pre-computed. Okay, using factorial of n into inverse factorial of n minus r. Inverse factorial of r. Okay. NCR is n divided by n minus r factorial r factorial. Okay, so these two pre-computations are done in order of n, which is 26. After that, my select is NCR n minus k plus 1 ck. That's what my select function was, as I have proved above. It was n minus k plus 1 ck. N minus k plus 1 ck. And what was my func? This func was the summation of this summation. Okay, so I have run a loop. If m is odd, then I do a minus sign, otherwise a plus sign. Okay, if m is odd, I do a minus sign of this factorial of n minus m into kcm. Factorial of n minus m into kcm. And if m is even, then I do a plus sign, same thing. Okay, once I have done that, I return my final answer. Okay, so these two functions are done. Then what is my final answer? C is the count of all the minus ones. Okay, and then my final answer is this thing. The two cases. So basically, this whole thing I've written here. Select this into func this plus select this into, and then I've multiplied it with factorial of C. Okay, that's how I got my final answer. I hope it is clear to you. Your time complexity, this is going to take, and whatever is the size of array, order of n time. This select function is going to take an order of 1 time, and this func is going to take order of k. So order of n minus 2k, and here order of n minus 2k again. Okay, so this is order of n minus 2k. Okay, and then this is simple over 1. So overall time complexity would be order of, okay, n, and n minus 2k is also n only. Order of n. The space complexity is going to be a simple vector of size n. Input vector only is used. So I hope this problem is clear to you. It was basically completely maths and combinatorial type problem. So, okay, I hope you got it. Thank you so much for watching. Goodbye.